What is the electron cloud model? The electron cloud model is a model of the electrons in the atom that was developed by Erwin Schrödinger and Werner Heisenberg. An electron cloud model isn't a representation of the atom, but rather the boundaries of where the electrons will move. You see, the electrons of an atom are attracted toward the nucleus by the electromagnetic force, and this force binds the electron inside the electrostatic potential well. In 1913, Niels Bohr proposed a model of the atom, and it works like this. There are a certain number of protons and neutrons in the nucleus of an atom, depending on its atomic number and its atomic mass. The atomic number determines the number of protons the atom has, and the atomic mass determines how many protons and neutrons are in the nucleus combined. Therefore, with basic math, we can find out the number of neutrons by subtracting the atomic numbers from the atomic mass. In Bohr's model, he proposed that electrons orbit the nucleus instead of orbit, and can only switch orbits via quantum jump. Quantum jumps occurs when the atom gains energy or loses energy. When it gains energy, the electron jumps to a further orbit from the nucleus, and vice versa when it loses energy.
It was however later discovered that Bohr's model is wrong in the sense that it is created under the assumption that electrons that orbit the atom are waves, not particles. But when scientists did the double slit experiment, it was revealed that light and matter can satisfy properties of both waves and particles, therefore making the electron both a particle and a wave at the same time. This concept is best described in Schrödinger's cat theory. This theory demonstrates a cat in a box with a container holding radioactive material. In a span of an hour, there's a 50% chance that this container will be opened and the cat will die, but another 50% chance that the container does not open, resulting in the cat surviving. Theoretically, if one were to perform this experiment and come back an hour later to check on the cat, to them, the cat would be both alive and dead at the same time.
Schrödinger's cat theory is used to describe one of the fundamental principles of quantum mechanics known as quantum superposition, and it states that a particle can be in a superposition of different states. The double-slit experiment was an experiment first conducted in 19th century. A beam of light is aimed at the vertical wall with two slits, and a black screen behind the wall is observed where the light hits. When one of the slits on the light is covered, the light from the source shines through the other slit and hits the rear screen. It would be assumed that if no slits were covered, the light on the black screen would line up with the slits. But that is not the case. Instead, the lights appear to be scattered and separate into multiple lightness and darkness that vary in degree. The Heisenberg uncertainty principle states that it is impossible to find out the location and momentum of the particle that has particle-wave duality. In other words, we can only precisely calculate the location or momentum of a particle. This therefore makes it impossible to calculate both the location of an electron in an atom and the speed of which it travels at. Schrödinger and Heisenberg realized this, and as a result create the electron cloud model of the atom.
The cloud model is a tool created for the purpose of predicting the location of which electrons in an atom would most likely be in. Because of the Heisenberg uncertainty principle, scientists have no way to figure out where they are, hence the name that Schrödinger gave to his model is a cloud, representing a space rather than a specific location. The cloud model works like this. Depending on the number of electrons or the energy level, the space in which electrons may appear will be different. There are infinite energy levels in an atom, but only the first four are observed to contain an electron, and the names given to those four are S, P, D, and F. In order to find the electronic configurations of an atom, we would have to list out the sequence of atomic subshell labels. The Aufbau principle states that electrons first occupy those orbitals whose energy is the lowest, and only when the orbitals with lower energies have been filled do the electrons move to the orbitals with higher energies. So for example, the 1s subshell is filled before the 2s subshell can be occupied by electrons. The order in which subshells are filled is 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, so on and so forth. And one of the way of remembering this order is plotting it down. So 1s to 7s, 2p to 7p, 3d to 7d, and 4f to 7f. As you can see on this graph, we can go from the top right to the bottom left diagonally, then back up, then down again, and we can find the order in which subshells are being filled up. And by applying the limit of which electrons can exist on subshells, we can find the electronic configuration of each element. Also, the subshells on the same horizontal line make up a full shell of an atom, and the outermost shell of electrons of an atom are considered valence electrons. Let's take the calcium atom for example. Its atomic number is 20, therefore the number of electrons in the calcium atom is 20. So minus 2 for 1s, 2 for 2s, 6 for 2p, 2 for 3s, 6 for 3p, and 2 for 4s. This all adds up to 20, therefore the electronic configuration of the calcium atom is 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. Let's look at another element, bromine. Bromine has 35 electrons, so it's basically the same process. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. Since this all adds up to 36, and bromine has 35 electrons, it is unable to fill the last shell, so therefore its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. Of course there are exceptions to this, like lawrencium and uranium, but this is the basic concept of electronic configurations. Once we know the electronic configuration of an element, we can then find out the atomic orbital of the electrons. An atomic orbital is basically the space of which electrons will most likely be in, since we can't find out their exact location and speed as previously mentioned. We now know that subshells with lower energies will be filled up first before electrons can occupy the subshells with higher energies. Therefore, the electrons have to fully occupy the smaller orbitals for the bigger orbitals will be filled. So if we go back to our example, the electron cloud of calcium atom would look like this, and same thing with bromine atom. This basically concludes my explanation of the electron cloud model. Thank you for watching this video.